today we will solve questions from past papers. Question number 1 is the cubic equation x cube plus ax square plus bx minus 40 equal to 0 has 3 positive integer roots. 2 of the roots are 2 and 4. Find the other root and the value of each of the integers a and b. So it's a cubic equation. So one of the root is 2. So you can write x is 2, x is 4. And the third missing root is, we assume that it is c. So you can express this in factorized form, x cubed plus ax squared plus bx minus 40 equals to x minus 2, because these are factors of this cubic equation. So you can write equation in factorized form, x minus 2 into x minus 4 into x minus c. Because the coefficient of x cube is 1, so therefore you can write like this. Now you multiply them and write x squared minus 6x plus 8 into x minus c. Now you further expand it and you write here x cubed minus cx squared minus 6x squared plus 6cx plus 8x minus 8c. And then you can solve like terms, minus c minus 6x squared plus 6c plus 8x minus 8c. And when you compare it with the coefficients of the terms on the left-hand side of this equation, then you can compare them and write down the values. Like you here compare it, you see that coefficient of x cube is 1 on both sides and coefficient of x square is a here, and on the other side the coefficient is minus c and minus 6. Similarly, coefficient is b, and on the other side it is 6c plus 8, and coefficient is minus 40 on the right hand side, and on the right hand side it is minus 8c. So when you solve it, the answer of c is 5. And similarly, when you solve it, substitute this value of c, answer is 30 plus 8 is 38. And when you substitute this value of c here, so a is minus 11. So this is how you can find the values of a, b, and c. Now you will back substitute this value in the original equation in order to solve the another part of this equation. Because the other part is, do not use a calculator in this question. Solve the equation this, given that it has 3 integer roots, only one of which is positive. So you have to find the roots of this equation, and given that one of the root is positive, it means the remaining roots are negative. So you can use hit and trial method to find first one of the root. Integers means that you are not supposed to take any negative value. We'll take only positive value. So you can use a remainder effective theorem to find the root, or secondly you can use synthetic division. So we'll do this question from synthetic division. First you write factors of minus 40. So it can be 1. So you can write plus minus sign. You can use 1 and minus 1 to try, or plus minus 2 because 2 is also a factor, or 5. It can be 8, 20, or 40. So these are possible factors. So you will try with these numbers. So because only one of them is positive, so we try with minus 1 first. And how do we do synthetic division? First, we write coefficient of each term. Coefficient of x cube is 1. Coefficient of x cube is minus 5. Coefficient of x square is minus 5, coefficient of x is minus 46, and the constant number is minus 40. Then you write a number. We assume that minus 1 is its factor and check whether it's a factor or not. You write this one as it is, and then you multiply this 1 by minus 1 and write it over here. Now you solve minus 5 and minus 1 is minus 6. Then you multiply minus 6 and this minus 1, and your answer is plus 6. When you solve minus 46 plus 6, your answer is minus 40. And then you multiply minus 40 by minus 1, your answer is plus 40. And when you solve minus 40 plus 40, your answer is 0. Because this shows the remainder is 0. And if remainder is 0, it means that the value of x is minus 1, and x plus 1 is one of the factor of this equation. Now you have to find remaining two factors. And to find remaining those two factors, you can express this whole expression into a quadratic equation. Like you can write here x square minus 6x minus 40. Now you can factorize this expression. 10 and 4 minus 10x plus 4x minus 40. X minus 10 plus 4 to x minus 10. So factors are x minus 10 and x plus 4, and one of them is x plus 1. So this is factorized form of this expression, and because it is an equation, so you write it equals to 0. And how can you solve it? Find the values. Once you know how to factorize, then you can find its value as well. So the answer is x is minus 1, x is 10, and x is minus 4. So now you can see we have two negative roots and one positive root. So the answer is minus 1, 10, and minus 4. Now you do another question. The roots of the equation are 2 and 3. And given that and p, where p is an integer, find the value of p. It's almost similar to the previous question. So you will use the same technique here. So 2 and 3 are the factors. So you can express this equation in its factorized form. Like you will write here x cubed plus ax squared plus bx plus 24 is equals to x minus 2, x minus 3 into x minus 3. Now, this is factorized form of the above expression. Now you can multiply them, expand it, and when you expand, your answer is minus 5x plus 6. Now you can again multiply it. X cubed minus px squared minus 5x squared plus 5px plus 6x minus 6p. Now you can solve like terms and write minus p minus 5x squared plus 5p plus 6x minus 6p. Now you can compare both sides of the equation. On left hand side, we have expression ax squared plus bx plus 24. Now when you compare, you get a is equals to minus b minus 5, b is equals to 5p plus 6, and 24 is equals to minus 6p. So using this third equation, you can find value of p, and p is minus 4. So that a is minus 1, find the value of b. Similarly, you substitute this value of p in this equation, which is a is equals to minus p minus 5. We write this a is minus p minus 5. Now we substitute value of p, which is minus 4 here, will be 4 minus 5. So a is minus 1. Similarly, you can substitute this value of p, which is minus 4, in this above equation. B is equals to 5p plus 6. So it will be 5 times minus 4 plus 6. This is minus 20 plus 6. So it will be minus 14. So this is how you can find value of A and B as well. Now we move to next question. Next question, it is given that the polynomial p of x is equals to 6x cubed plus ax squared plus bx plus 2, where a and b are integers, means not in decimals, not in fractions, whole numbers, has a factor of x minus 2. Given that p of 1 is equals to minus 2 times of p of 0, find the value of a and of b. Now you are given three things here. One of them is it has a factor of x minus 2. Because x minus 2 is a factor, so it means you can substitute this value in the polynomial. You can plug in x equals to 2 in this above polynomial, and you can write here, and because it's a factor, so remainder is 0. So you can make an equation of the type, substitute 0 here. So all this, 2 here, plus b into 2 plus 2 is 0. 48 plus 4a plus 2b plus 2 is 0. So there are two unknowns a and b, so we must have two equations, and then you will solve them simultaneously. So it is minus 50. This is equation number 1. Now we'll use second condition. Second condition is that p of 1 is equals to minus 2p0. Now you will substitute 1 in this equation and then 0 and connect them. So you will write here 6 into 1 cube plus a into 1 square plus b into 1 plus 2 is equals to minus 2 times of p of 0. When you substitute 0, all these terms become 0 involving x. You left with only this constant 2. This is how you get a third equation. Now we have two equations. Now you can solve them simultaneously. You can write it as 4a plus b is equals to minus 12. Multiply it by 4. So you get 4a plus 4b is minus 48. Now you write the first equation. And solve it. 2b is 2. So value of b is 1. And when you substitute this value 1 in the above equation, which is a plus b is 12, then you can find value of a as well. So a is minus 13. So this is how you can find value of a and b. Now next question, next part is using your values of a and b, find the remainder when p of x is divided by 2x minus 1. So we'll use remainder theorem. First we substitute values of a and b, and the equation becomes p of x is equals to 6x cubed minus 13x squared plus x plus 2. It is divided by 2x minus 1. So first you find value of x, which is 1 by 2, and substitute this value here. Now you here write 6 by 8 minus 13 by 4 plus 1 by 2 plus 2 is 5 by 2. And then you can write here, this is 3 by 4. 3 by 4 minus 13 by 4 is 10 by 4, which is minus 5 by 2. And minus 5 by 2 plus 5 by 2 is 0. So this is how you can find value of remainder when p of x is divided by 2x minus 1. Last part of this question is you have to factorize this polynomial. In polynomial, when you factorize, you basically know when you divide this whole polynomial by this 2x minus 1, then your answer is 0. It shows that this 2x minus 1 is a factor of this polynomial. So if it is a factor, then you can apply synthetic division to solve it. So first you will write to get another factor. With the help of synthetic division, you can get another factor of this. So the coefficients we write here 6 minus 13, 1 and 2. These are factors of the, these are the coefficients of the each term of the given polynomial, and 1 by 2 here because it's a factor. And now we do synthetic division. You will write this 6 as it is. And then you multiply 6 by 1 by 2, you get 3. Minus 13 plus 3 is 10. When you multiply, you get 5. Minus 3, when you multiply minus 13, and when you multiply it by 1 by 2, your answer is 3, and this is minus 10, and then it is minus 5. Minus 5 plus 1 is minus 4. And when you multiply minus 4 by 1 by 2, your answer is minus 2. And minus 2 plus 2 is 0. So it shows that 1 by 2 is a factor. And with the help of this, which is the second, with the help of these numbers, you can form a quadratic equation. So a quadratic equation is 6x square minus 10x minus 4. Now you can factorize it, this quadratic equation. Your answer is, make factors 6x square minus 6x minus 4x minus 4. Now we can take 6x as common. Answer is x minus 1. So factors are 6x square minus 10x and minus. So you multiply, your answer should be 24, and you took 12 and 2. They are factors. Minus 12 and plus 2. Now you can take 6 as common. And when you take 2 as common, so it is 6x plus 2 and x minus 2. You can also take 2 as common from here and can write 2 into 3x plus 1 and x minus 2 and x minus, this was one of the root of the equation. So this is how you can express, how to factorize it. So the root, you can write p of x is 2 times of 3x plus 1, x minus 2, or further you can take LCM here and write 2x minus 1 and can simplify. So this is your final answer, 3x minus 1 into x minus 2 into 2x minus 1. Now we do more question. Question is, the polynomial p of x is this, where a, b are constant, has factors, has a factor x plus 4, means when you substitute x equals to minus 4 in the given polynomial, your answer is 0 by using factor theorem. So you have to show that, and also you are given a further condition, like the main points are, key points are that it has a factor x plus 4, and second is 2p1 is 5p0. So these will be helpful to find the value of a, b, and c, which are constant, right? So you can write ax cube plus bx square minus 19x plus 4. This is polynomial p of x. Now it is given that x value of x plus 4 is its factor. So you substitute here x is equals to minus 4. So when you substitute x is minus 4, your answer is 60 minus 64a plus 16b plus 76 plus 4 is 0. When you substitute this value here, now you can simplify. Your answer is minus 64a plus 16b plus 80 is 0. Now you can take 16 as common, and your final equation is minus 4a plus b plus 5 is 0. So this is equation number 1. Now you will make second equation by using this condition. 2p1 is equals to 5p0. So you will write here 2p1 means you replace x by 1 in this equation. And when you substitute x equals to 1, your equation is a plus b minus 19 plus 4 is equals to 5 times of p0 means you need to substitute 0 in this equation. So all these terms become 0 and you left with only 4. So we get another equation 2 times of a plus b minus 15 is equals to 20. Now you can divide it by the equation. You can write here a plus b minus 15 is equals to 10 and a plus b is equals to 25. It's the second equation. Now we will solve these equations simultaneously. So you will write here minus 4a plus b is equals to minus 5. When you solve them, 5a is equals to 30. It means a is 6. Now you substitute this value in the equation and you get 6 plus b is 25 and b is 25 minus 16, which is 19. So this is how you can find value of a and b. But this is not the factorized form of the equation. You just solve for a and b. Now you substitute these values in the polynomial and your polynomial becomes p of x is equals to 6x cubed plus 19x squared minus 19x plus 4. Now you see we have to express this polynomial in the form this. This one means as in the form of product of one linear and one quadratic expression. So one of the linear means it is already given that x equals to minus 4 is a root, x plus 4 is a factor. So it means x equals to minus 4 because it's a factor. So the 6 as it is minus 24 is 5 and 5 4 times is minus 5 and minus 5 minus 4 is 20 and 20 minus 19 is 1 and 1 into minus 4 is minus 4. So the answer is 0. Now this is our quadratic equation 6x squared minus 5x plus 1. So this is how you can write x plus 4 into this. This is the required expression. Now you have to factorize it completely. Now you can factorize it. You can write here x plus 4 is linear. Now you divide it into two parts, midterm breakage rule. So 3 and 2 are factors. When you multiply, your answer is this. So we take 3x as common, so 2x minus 1. Minus 1 is common, so 2x minus 1. So your answer is x plus 4, 2x minus 1, and 3x minus 1.